Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss response to sinusoidal signals. That means what kind of response we get when the input to the system is sinusoidal in nature. For this, we are going to make use of the result that we have already derived. I'm going to say that if input to the system x1n is, let's say, e raised to j omega naught n. Now this is complex exponential signal. I'll take some magnitude a. For this, we have already found the output y1n, if you remember, was of this form. The same input comes at the output side, a e raised to j omega naught n multiplied by h of omega naught, where this h of omega naught was nothing but h of omega, where omega is replaced with omega naught. So omega naught is a constant, so obviously we find out the value of capital H at omega equal to omega naught and put it here. Now, in general, please remember that h of omega naught can be a complex number, and hence its magnitude will get multiplied by a and its phase will get added with omega naught n. So I can further write this as a magnitude h of omega naught multiplies with a, and the overall function becomes e raised to j omega naught n plus I will add phase. Now phase, we can use the notation phi of omega naught. So this becomes my y of 1 of n. Similarly, if I now take the second signal, which is also complex exponential signal but slightly different, a e raised to minus j omega naught n this time. So there's a minus sign here which is different from the previous signal. So what will be my output in this case? Output in this case will be a e raised to minus j omega naught n. Same input comes at the output side, and this time we will multiply with h of minus omega naught. Now if you remember, like h of omega naught, h of minus omega naught will also have magnitude part. So mod h of minus omega naught into e raised to minus j omega naught plus I will take phase of minus omega naught. So if you remember, magnitude response was the E1 function, and hence E1 function does not get affected even when the variable is replaced with minus sign. So h of minus omega naught will be h of omega naught into e raised to, if you remember, phase function was an odd function. So odd function means phi of minus omega naught will be minus phi of omega naught. So there will be a minus sign here, there's a minus sign here. So if I take minus outside, I'll get j omega naught n. Minus I've taken outside, so I can now write it as plus phi of omega naught. So this is my y1n, this is my y2n. Now how are we going to use these two results? So now I'm going to say that let us define the third signal. Third signal, which is x of n, will be defined as half x1n plus x2n. So it is a linear combination of the two signal, and because my system is linear, I need not find y of n separately. Y of n will be exactly the same linear combination, so it will be half y1n plus y2n. We already know y1, y2, so I can find out the corresponding output.